We're now going to look at solving logarithmic equations. The first one is another kind of special case where we can kind of bypass the general method. We're going to combine both sides. So remember, if we're adding, that means we're actually multiplying. So this would be log base 4 of, if I multiply 3 times x plus 2, I'd have 3x plus 6. On the other side, again, I'm adding. So that means I'm actually multiplying 5 times 2x minus 3, which will give me 10x minus 15. So since it's log base 4 of these two things on both sides, kind of consider like I'm dropping the logs out. It's not really what's happening, but essentially I'm saying the 3x plus 6 has to equal the 10x minus 15. And if you solve that for x, you'll get that x is 3. So again, that was kind of a special case where I could just drop the logs out. In general, I want to do the loop-de-loop. So to solve a logarithmic equation, on the previous lesson we were doing exponential, now we're solving logarithmic. We want to isolate the logarithm. So on letter A here, I'd have to subtract over the 7, so that would give me negative 3. So the 7's gone. I would divide out the negative that's in front of the logarithm, so that would leave me with 3 equals log base 2 of 25 minus x. If it'll let me write. There we go. So now that I've isolated the logarithm, I'm going to do loop-de-loop to convert it to an exponential. So exponentials, we convert it to logs. Logs, we're going to convert to exponentials. So I'm going to loop-de-loop this. So this means 2 to the 3rd equals 25 minus x. So 2 to the 3rd is 8. If you solve that for x, you're going to get that x is 17. A little note, by the way, when I am dealing with logarithmic equations, this didn't come up with exponential, but remember that you can only have the log of a positive number. It has to be greater than 0. So make sure that your answer doesn't give you the log of 0 or a negative. If I plugged in 17, that would give me the log of 8. I'm okay. So the answer is allowed. We'll see something different here on letter B. I've got 2 logarithms that I'm adding, so I'm going to combine those using the product law. So if I multiply x plus 2 times x minus 1, if I FOIL that out, I'd have x squared plus x minus 2. Okay, so I've got a logarithm that's isolated. I'm going to do loop-de-loop on this. Remember, if there's no base, it's base 10. It's common log. So 10 to the 1st equals that whole x squared mess. Looks like I've got a quadratic, so I'm probably going to end up factoring here. So if I subtract over the 10, I have x squared plus x minus 12 equals 0. Which does factor. It'll factor into x plus 4, x minus 3. So that gives me x is -4, x is 3. But remember, I cannot have the log of 0 or a negative. If I plugged in -4 for x, it would cause the log of a negative. If it does it anywhere, it's out. It does it actually in both of them. So that answer has to be tossed. 3, however, if I plug it in, we're good, we're good. So 3 works. And just a reminder, it's not did I get a negative for x, it's does it cause the log of a negative or the log of 0. So be careful when you're doing log equations. We may have to toss some stuff. On letter C, again, I'm adding, so I'm going to multiply these together. So x times x minus 3. Okay, now do the loop-de-loop to turn it into an exponential. So 2 squared equals x squared minus 3. Minus 3x, excuse me. Looks like another quadratic. So if I subtract over the 2 squared, so subtract over 4. Hopefully this factors, and it does. This will factor into x minus 4, x plus 1. So I get answers of 4 and -1. But again, I have to test those. -1 would cause the log of a negative number, which is not allowed. 4, however, is okay. So 4 is the only answer that ends up working. On letter D, it's natural log, but it's already log isolated. So I'm going to do the loop-de-loop. Remember, the base is e. So e to the first, which is just e, equals 2 plus x. I'm trying to isolate x. So e minus 2 is what x equals. And that's an exact answer, so I'm just going to leave it. If your homework asks for a decimal approximation, you can throw it into a calculator. If I plug that in, that will not give me the log of a negative or 0, so we're okay. Our last 2 problems are asking for the inverse of the function, and we're going to use the idea that logs and exponentials are inverses of each other. So in general, remember, if we're doing an inverse, if we think of the f of x as your y, remember, in inverse, we switch the x's and y's. So this would be x equals 7 to the negative 4y. And now I'm going to get that y by itself. How do I do that? Well, what gets exponents out? Logarithms do. So I'm going to log both sides. That lets me take the exponent and bring it around town. So I'd have, let's see, log x equals, if I bring that exponent around town, negative 4y log 7. Again, I'm trying to get y by itself. So I would divide over the log 7. So that's gone. And then the last step would be to divide by negative 4. So if I divide by negative 4, I can just think of that going in the denominator as well. So I'd have that y equals, and I'm going to change that to f inverse in just a second. If I divide by negative 4, I'd have log x over negative 4 log 7. And that's what my new y is. But remember, that's also the inverse, so I'm going to use inverse notation and call it f inverse of x. And there are ways you could clean that up a little bit. You could maybe take the -4 and bring it around town to an exponent. So it could be 7 to the -4 there. Not all that helpful though. For letter B, again, consider f of x to be your y. Switch your x and y. So now it's x equals log base 6 of y plus 3. I'm trying to get that new y by itself. So what undoes logarithms is exponentials. So I'm going to do loop-de-loop, convert this to an exponential. 6 to the x equals y plus 3. Then I just subtract over the 3. So I'd have 6 to the x minus 3. And instead of calling it y, again, I'll use inverse notation and call it f inverse of x. And there's my inverse of the function.